I will actually do this just like you. So if you have this in your calculators already, you don't need to type it in again, but I'm going to do it one more time. Oops. So negative 17.89. Before we even graph it, I'm going to enter this. Before you even graph it, you should have already picked up on a few things. First of all, it's not general, right? This is in vertex form, which the word vertex tells you this gives you the vertex. If you look at it, and I'm sure some of you figured out, wait a minute, my vertex was 1520, right? Some of you saw that. I don't know if you noticed that or not, but you could have actually just looked at this and figured it out. We know that A is negative, so I'm expecting this to be pointing down, which means that my vertex would be a maximum, right? It would be the greatest point possible on this graph. So just by looking at it, you already know, okay, got it, okay? So coordinates of the vertex, I'm going to graph this with you. So you graph it, don't see a thing, right? So I'm going to use zoom fit, that's 0, option 0. It gets you started, but you still need to see more. I'm sure you figured this out after a while, right? So I'm going to go X max 50. That's a pretty good window. And you don't know, you have suspicion that this crosses it once, more than once. We don't know for sure yet. Let me introduce you to another zoom. Zoom in. Zoom in, if you want to use it, you select it and then you take your cursor where you want to zoom in to. So that's always there for you to use. You keep hitting enter and it will go closer, watch. Right? If you keep hitting enter, can you see it there that it's crossing it more than once? So that's an option too. How do you get back? You go second trace, sorry. Zoom out, right? So I select that one and I'm just gonna keep hitting enter to zoom back out. Okay, so that's always there for you. I didn't talk about it because I didn't want to overwhelm you, so I'm gonna slowly just add layers that will help you out. So there we go. We have everything we need right here. So I'm gonna just find the vertex either by looking at this. I could just say that it is 15. The sign of this changes, okay, but not the y value of the vertex. So that's my vertex. It's a second trace maximum. You go to the left. You know the drill. You were pretty good at this part. So that's 1520. Confirmed. Number of x-intercepts, I will just say 2. I want to use the bottom for the graph, 2, because it crosses the x-axis twice. And later on, I'll explain to you how you could have predicted that as well without even graphing it. And this is why. A is negative, so we know it's doing this. What do we know when we look at the 20? What do we know about the vertex? It's positive, right? The y value of the vertex is positive, which means this thing is above the x-axis. So it crosses it twice, right? So you could have looked at this and figured that out. Don't worry about it too much because you can always just use your calculator if you're really stuck. But, you know, I like to have ways to verify what I'm doing. The y-intercept, this is probably the one that some of you were like, can that be, right? Second trace 1, make x equal to 0, so that is 0, negative 4005, 25. Coordinates of the x-intercept, we're going to do this again. So if you're not sure, you first come in from this side, so you hit enter, enter, enter. That's 1394, okay? So that's 1394. You should, I would say you should write it down just in case, right? And then the second one, if there's another one, I'll find out by going, I'm going to go this way and approach it from this side, and it will stop at the earliest intersection. So that's 16.060, right? So there you have your two x-intercepts. Now we're going to graph it. So here's, if you have a ruler, this unit and next unit, not the next one, but chapter 6 will require you to graph as well. So it's good to have a ruler with you. But here's what I'm going to do. I have all my intercepts. I have my vertex. Look at the calculator. Like, what does this look like? This is more towards the right, the positive axis, right? And so it's basically quadrant 1, 2, 3, 4. Most of it is in here. So it's something to keep in mind. So I'll do it. I'll kind of devote less space for the other quadrants. Okay. Oops. So that's how you start. You just make your axes. This is the x, this is the y, and now you need a scale. My y-intercept is in the -4,000. That's what I'm going to focus on first and foremost. So maybe I'm going to go 1,000, 2,000, 3,000, 4,000, like that. And it's okay to label every other line as long as you're consistent. I talked to you about the spacing. Make sure it's spaced out the same way. And therefore, going up is also, this is also 1,000 here. Okay, positive. And then along the x-axis, I can just go up by 5s. So 5, 10, 15, 20, right? So I'll label every other mark. I do the same thing going into the negatives here. This is -10. And so now I plot my points. So -4,005 is right about there. 13, this would be 15, so 1394 is there. 1606 is there. And 1520 is right about there. So it's just a little poke above the x-axis. So then you take your pencil, go out, and make sure it curves out like this. But it doesn't curve into itself, right? You want it to curve out like that. You grab the other side and mimic it. Okay, there you go. You could have just gone just a little bit, it's fine. And so this has the equation h of t is -17.89 x minus 15 squared plus 20. Okay, so there's your graph. That would have everything that I would expect it to have on it, and you get full marks for the graph. Okay. All right, so be prepared for more of these down the road. Okay. All right. If you could grab your notes now, and I'll just cover a concept that is going to be handy down the road. We're going to go to page 12. Page 12 says finding the equation of axis of symmetry, AOS. And here it is. Since a parabola is symmetric, just fill in the blank, right? You'll notice that my booklets focus way more on examples, copying examples, than the actual written pieces, right? Because I want to get to it, right? Points on either leg are equidistant. What is that weird word? From the AOS. So points on either side of the leg are going to be the same distance from the center, right, on either leg. So if you're given 2 points that have the same y value, that's important to highlight. Okay? 2 points that have the same y value, they are at the same height. so to speak, we can find the value of the AOS using, here it is, the equation. So for the AOS, that's how we call it, but we actually state it like this as an equation. So you take the first x value of the first point, the second x value of the second point, make sure you have that in brackets, then you split it in half. That's how you find it. Where x is the axis of symmetry, AOS, x1 is the value, x value of first point, x2 is the x value of point 2. It's nothing really that new, it's just an important concept to have in mind, right? So just make sure you add this to your study sheet, right? That's how, if we don't know the vertex, then this is how we, another way to find the axis of symmetry, because remember, it is the x value of the vertex, essentially. So here's an example. Determine the equation of the axis of symmetry. Okay, they want the AOS. Sorry, I should have underlined symmetry as well, of the parabola below. Okay, so let's make sure we add arrowheads everywhere. Call it x, y, and there you have it. So visually, we know that our axis of symmetry, I'm using a red pen for this part. If you can find the vertex, which we know is here, okay, we know that the axis of symmetry would travel right through it. Okay, I'll make it a dashed line. Do we know the coordinates of the vertex just by looking at it? I think we do, right? Because this is this would be 2, 3. So the vertex is 2, 3. But remember, you will probably not have the graph given. I'm just showing you on the side what's happening. So the AOS, we know is x is equal to 2, right? It's the x value of the vertex. We know that already. But we're going to actually show how that can be calculated. Let's grab, remember they have to be at the same height. So these 2 points are at the same height. If you travel along both legs, right, we're going to use these 2 here. Okay, so using, it doesn't matter which one you pick first, but they have to be at the same height. And 6, 11, we would be able to, you would notice this. Oh, these points have the same y value, which means they're right across from each other on either end of the leg, right? So this is going to be our x1. This is going to be our x2. Remember, it doesn't matter which one you call x1 and x2, just make sure you distinguish between them. So we would say that the axis of symmetry would be -2 plus 6, and I'll put square brackets in there because I need to make sure you add before dividing by 2. -2 plus 6 is 4 divided by 2, which is 2. We already knew that. We already knew that our axis of symmetry is 2 because the graph was given to us. Right? So it jives. One more. Using using 0, 5 and 4, 5, you notice that they have the same height, which means they're right opposite each other. X is equal to, this is x1, this is x2. So you go 0 plus 4 divided by 2. Guess what? It's still 4 divided by 2. It is still 2. So the axis of symmetry doesn't change. Maybe I'll just write the orange there. Got the 2 there and the 2 there. So we've determined that with all of them. So last but not least, therefore, the axis of symmetry, remember you can't just say it's 2, is x is equal to 2. Okay, that is the axis of symmetry. It's the equation. Almost done. For the examples down here, I'll just make that homework. So write homework and next to it. And I'll scan and post that. You know what? Before we move on, can I just I'll show you at least, if you were to look at any 2 points that are across from each other and you draw a line from end to end, right? That'd be the total distance between the 2 points. You would still have to say that this is the same distance as this. So from this leg to the center would be the same thing as going from the other leg to the center, right? So we go, let's go 2 lines like this and 2 lines like that, telling you that those 2 segments are the same length. Just to emphasize the point. Okay. All right. One more example. We're good? Okay. I'm going to go to page 13. Finding the missing value, missing x value, using the axis of symmetry / vertex. Okay. So you're given 2 points that lie on the parabola and the vertex. Notice this, that the 5 and the 5, it tells you they're on opposite ends on either leg, right? These 2 points are across from each other. And the vertex. What does the vertex tell me? Well, the x value of the vertex is actually the AOS. It's already given. So we know that the AOS is x is equal to 6. Okay? So we're not finding it, we already know what it is. But we can use it to find missing information about one of the other points. Okay, you need to zoom in for that or what? Let's do it. It's going to stay there pretty much. So here it is. Come on, you can do it. You can do it. There we go. Okay, so we approach it the same way. This is x1. This is x2. And guess what? X is already given. Okay. So we'll go x is equal to x1 plus x2 divided by 2, making sure they're in brackets. The top is in brackets, but I'm not going to put that in just to make it easier, but you need to know you add and then you divide. So the 6 goes in here. Okay, guys? This 6 goes in there. So we'll go 6 is equal to x1, which we know is 3, plus x2 divided by 2. All right, so now what? Now we do some algebra. It's like backwards. Okay. We multiply this both sides by 2 to be able to cancel that out. That is 12 is equal to 3 plus x2. We subtract 3 from both sides. x2 is equal to 9. Okay. Therefore, the second point is 9, 5. Okay. You just found that second point that we didn't know the x value for. That had a question mark here. We now know what it is. Okay. I'm going to also ask you to do the rest of this page for homework. I didn't give you a textbook, did I? I did. So at the bottom of this page, there's there's higher pages that's a textbook, but don't worry about it. So just pages 12 and 13. Pages 12 and 13, that's all you're doing. A lot of it is just reviewing what we've done before. So just wait for the key and make sure you practice that.